Oil is the lifeblood of the machine, and here at the lab, we test that oil to make sure everything is healthy or provide suggestions on how to keep those costly repairs at a minimum. Testing that oil allows you to know if your oil, filter, and maintenance schedule is working or not. But how does that process work? Let's check it out. Hey Chris, how's it going?
Hi Jaron, welcome to the Fluids Lab.
Thank you for having us. This is Chris Palmer. He's the manager of the Fluids Lab. And Chris, how long have you been working here?
So I've been with Warren Cat in the Fluids Lab for 6 years now. So I was here when the lab actually got started. I was brought on as the technician to start unboxing the instruments and getting them operational so we can start processing samples.
Yeah, and kind of what got you interested in it?
So really it was the instrumentation initially is what brought me on. I love kind of how things pulling things apart and understanding how things work. And then as I kind of got into it, I really liked the whole process of what we do as a whole picture for our customers.
Yeah, and so why don't we actually go check out what that process is?
All right, come on, this will be great. So here's where all the magic happens.
All the magic right here.
All the magic right here. So what happens is samples are brought in every day and we'll start to sort them out here on this table. And what we're going to do is we're going to break them up based upon their compartments. So we've got our hydraulic systems, our transmissions, our engines, and then everything else is a gear, is what we consider.
Yeah, and how many samples do you get each day?
That's a great question. So a lot of times it depends. It could be a lot, 500, or it could be 150. We typically average about 12 to 1,300 samples a week.
And I bet during those samples you've seen a lot of crazy different samples.
There are some
crazy stories.
Oh yeah, absolutely. So like here's one, for example. This is a hydraulic system that's milky. Obviously it's contaminated with something, probably either water, maybe it's DEF, we're not really sure. We're gonna continue to test it and maybe identify what's going on. We're gonna start to pour them up into a test tube. So a 4-ounce bottle goes to a 1-ounce test tube. So once we have our samples in our test tubes, we're gonna bring them over here to the auto diluter. So from here, we're going to take our undiluted samples in test tubes and we're going to dilute them with kerosene. And what that does is that thins that out so it can go into our instrumentations and process appropriately. So these undiluted samples are also, after we've taken a little portion out, come over here to our IR. And this is where we're looking for things like soot, oxidation, sulfation, and that tells us, is the oil degraded? Is there like high soot, which could be a certain thing like maybe that's a lot of idle time or something. So we're going to take that into consideration for the customer. Now those diluted samples are going to come over here to our ICP.
This is the big machine.
This is the
fun one to watch.
This is one of my favorite ones. So this is the ICP, and what this is it has that argon plasma flame that we're going to take that kerosene sample and push it through, and it's going to burn it up. And just like when you've been camping and you have those little packets you throw in the campfire and it makes all sorts of cool flames, that's exactly what's happening here, because each one of those colors is a metal that you would be looking at.
And this has a part that is also used in the Hubble telescope.
That's right. So the same optics that are in the back of this are the same optics that are used in the Hubble telescope. And the raw data that we would actually see actually looks like a star map. So bright stars are like high concentrations of metals. Dim stars are low concentrations of metals. And so that allows us to have great precision in seeing these 18 different elements all at the same time. Yeah. That's kind of the nature of the test tube samples. Those bottles of samples we're going to bring back over here to this table. So we have them flipped upside down because we're going to start doing what we call the large particle analysis, which is a lid test is another word. We're going to take each sample and we're going to open it up after it's set on its lid and look to see if there's any large debris. This is a clean sample, so that's what we want to see.
Do you see large debris often?
Sometimes we do, especially more like in the gears, things that kind of get dirty. See, like here's an example. See, like that looks like there's probably a lot of dirt, so maybe that's a bad sample technique, or maybe there's actually a dirt in the system. And so we're gonna actually test that, and we'll see that on the ICP that we talked about. We'll actually see the elemental components of dirt. On this wall, we're going to do our particle analysis where we actually get an ISO code. So if you're in the shops and they're talking about cleanliness, they're going to maybe talk about ISO code. Here's where we actually measure that on the samples here in the lab. This next part is we're going to move over to our hot plate. And this is a hot plate that's 160 degrees Celsius. And we're actually going to take a little sample and strike it across, and we're going to see if it boils. This can also be called the crackle test because if there's water, it's going to sound like bacon on a hot pan. And then we come over here to our viscometers. And this is where we're actually going to test the viscosity or the weight of the oil. So is it a 10 weight? Is it a 30 weight? Is it a 40 weight? This will tell us what it is. And that's important because if it's an engine oil, maybe it's diluted with fuel. Maybe there's a bad injector or something like that.
Yeah, and how long does the whole process take from the very start to, I mean, obviously if you add the coolant part and you have to do a little extra, but outside of that, how long does it all take?
So our turnaround time is a 2-day process. 1 day is going to be in here in the lab where we're actually collecting all the data from the various different instrumentation, and then 1 day for doing the interpretation, where we actually look at the data, we look at all the information that was on that slip, what is the make, the model, the year, the component, what's the sample history, and then write that recommendation.
Yeah, and just elaborate on that a little bit, how big of a benefit it is, what you guys do for the customer.
One example specifically, we had a customer pull the sample, and for some reason they delayed in getting the sample to us, so it took a month before we actually got the sample. We got that sample on a Tuesday, and we processed and got those results out to them on Thursday, just our normal process. Unfortunately, on Thursday we told them, stop the machine, failure is imminent. Unfortunately for the customer, the Tuesday that we received the sample, they had a piston go through the block of a 3512C, which is a very large engine and a very costly repair for them. Since then, lessons learned, that customer now overnights their samples to us directly to reduce that travel time as much as possible, so that way they can be as proactive in their maintenance.
Yeah, so what you guys do is a big part of the whole process and very important.
Absolutely. So, and that's our goal at the end of the day, is we're looking for the component health for our customers, for their machines, to make sure that they're maximizing the product that they have. Because the last thing we want is to have an unexpected catastrophic failure.
Yeah, well, thank you so much for the tour today.
Absolutely, Jaron. I appreciate you coming by.
Well, as you can see, there is a lot that goes into making sure your fluid is working at a healthy and high level, and it only takes 2 days to get your sample back, but at the end of the day, could save you a lot of money.